The diameter of a borewell machine is about 6 to 8 inches, but the tunnels built for roads and railways usually have a diameter of 15 to 20 meters. One of the biggest challenges in tunnel construction is that the machine operates horizontally, so the soil or mountain above it can collapse. That's why we need large machines like the TBM. TBM stands for Tunnel Boring Machine, and it's extremely powerful. But these are built on demand, depending on the location of the tunnel. First, the soil and rock strength are studied, and the machine is designed accordingly. The TBM you see here is used to cut through mountains to make tunnels. Its length is over 100 meters, with multiple trailing units attached. These units are transported by trucks and assembled on site. At the very front of the machine is the cutter head, which chips away at stone. You might be surprised to know that the cutter head of the world's largest TBM has a diameter of 20 meters. The cutter head rotates slowly, and its front side has cutting discs that look something like this. These discs are made of high-strength alloy steel or sometimes tungsten carbide. They can rotate freely in place. As the cutter head presses and rotates against rock, the discs also rotate, creating cracks in the rock. Depending on the cutter head size, a certain number of discs are installed. For example, this large machine has 42 cutting discs. The discs are spaced far apart, so how exactly do they cut rock? That's interesting to see. For simplicity, let's look at just 3 discs. The cutter head applies tremendous force on them. The discs press into the rock, forming cracks along lines. Behind them, another disc is placed, so the cracks made by the first 2 are extended by the 3rd disc. Since stone is not flexible, the pieces between the cracks naturally break apart. So, in reality, the TBM doesn't cut rock, it creates high-pressure cracks that cause the rock to fracture on its own. If you look at the cutter head disc arrangement, it's designed just like this. Another important thing is that while the stone is being crushed, water is continuously sprayed onto the discs. This prevents overheating and extends their life. Now, the biggest challenge is, how do you push the cutter head forward? It requires enormous pressure. These cutting discs endure up to 20,000 tons of force, which is many times greater than the weight of the entire machine. Only a hydraulic system can generate such force. But before that, let's understand how the cutter head rotates. It's powered by 4 radial piston hydraulic motors. Some TBMs use electric motors, but because extremely high torque is needed, hydraulic motors are preferred. These are directly connected to the large gear of the cutter head. When we visualize such massive machinery, it becomes easier to understand. These 4 hydraulic motors are set in parallel, so they apply equal force. If you open one of these motors, the mechanism is simple. Each has 5 pistons, and its rotor is slightly offset from the center. The pistons push the rotor one by one, making it rotate. Each piston has 2 valves. When high-pressure oil enters one, the piston pushes the rotor, and as it returns, the low-pressure oil exits through the other. This cycle is repeated for all pistons, and the motor can't work alone. It's controlled by a control valve system which decides when and how much oil pressure each piston receives and when to release it. So even though the motor looks complex, it provides nearly unlimited power. That's why radial piston motors are used. Now, after the rock is fractured, the debris needs to be removed. For that, there's a drainage system. If the TBM is moving slightly downhill, gravity helps wash out crushed rock with water. But if the TBM is boring horizontally, then a conveyor belt system carries the debris out. At the tunnel exit, trucks are stationed to collect and transport the waste. Finally, the most important part, how is the machine pushed forward and held in place? Behind the cutter head are hydraulic jacks that apply 20,000 tons of force. This force is many times greater than the machine's weight, which is why Newton's 3rd law of motion works perfectly here.